I know some of you might still be working on these, but let's go ahead and see what you remember. So for the first one here, our cylinder, where would we start finding the volume? What's our first step in finding volume? Finding what? Okay, finding the area of the base, right? First step in volume is always finding the area of the base. And since this is a cylinder, the base is a circle, that area is pi times 4 squared, which comes out to be 50.24 inches squared. What's our next step? Okay, if we're doing it for surface area, we've got to add that in twice. You are correct. For volume, what do we do next? Well, it's just that area of the base, 50.24 inches squared times the height of 12 inches, which comes out to be 602.88, right? Inches cubed. How many of you had that for the volume? A few of you? Okay, good. Now for surface area, we don't need to figure out the area of the base again. We already have that, so we're going to have 50.24 and another 50.24 because there's one on top. What we need to figure out is the lateral area to add to that. How do we find the lateral area? Well, to find the lateral area, we need to know the perimeter of the base. Think of it this way. Now, this being a cylinder, if this is the cylinder, what we're doing is we're slicing it down the side and we're unrolling it. And see that circle that's on the end and the base, that becomes the length of our rectangle. We can unroll the sides to make a rectangle. So when we're doing our lateral area, the perimeter of the base is giving us the length of that rectangle. And since this base is a circle, what we're finding is the circumference of the circle. So that is going to be 8 times pi. Where'd my 8 come from? Diameter, double the radius, double the 4, which is going to be 25.12 inches. So that my lateral area will be that 25.12 inches times my height of 12 inches, otherwise known as 301.44 square inches. And I'm going to take that and add it to my other areas here. You get 401.92 square inches is my total surface area. How many of you had that one? Just 2 of you, okay. Well, I'm going to pause there for a second. Any questions? Let's go step by step. Volume, any questions on how we got the volume? How many think you could do the volume on your own? Surface area. Questions on where the 50.24 came from? That's just the area of our base when we did the volume. Yeah?
I'm not getting 602. I keep getting 3 something.
Did you divide by 2 somewhere? The 50.24 times 12. I get 602. Oh, yeah, you can't do the squared. That'd give you like 3,000 something.
Yeah, that's what I was like, that's where I went off there.
Yep, the square is just on the units. The square is not acting on the numbers at all. It's just a unit. It's just the difference between inches and pounds. It's inches and square inches. Yeah, mathematically that squared does nothing to the numbers. Unless we're doing conversions, which we saw a little bit. We'll review that again. Okay, So the 50.24, that is the area of the base, and there's two of them. There's one on bottom and one on top. So that's why we got 50.24 written down there twice under surface area. So then all we need to do then is find the area of this lateral area, which is the part that wraps around it. Lateral area, remember, is always the perimeter of the base, which is what we found here, the circumference of that circle, and then times the height, which was the 12 inches again, which gave us the 301.44. So we just added those three areas up to get our total surface area. Now the second one's a little bit different. It is a pyramid. We still start out finding volume by finding the area of the base. Now this is a 10-inch base here, so our area of our base is 10 inches by 10 inches, or 100 square inches. So that's the area of our base. To find our volume, we take that area of the base, 100 square inches, times our height of 12 inches, but what do we have to do to it? Divide by 3. Volume is three-dimensional, so we divide by 3 when finding the volume of a pyramid, which gives us 400 inches cubed. So the volume there is 400. Surface area. We start out with the 100 square inches, which is the area of the base. There is not a base on top, so we only add that in once. We don't have to put it in twice this time. For lateral area, we still need the perimeter of the base, which is just going to be 40. How did I get 40? Perfect. 10 plus 10 plus 10 plus 10 gives us 40. What else do I need to find the lateral area? Do I just take that 40 times 12? I need the slant. 12 is not the height of that triangle. 12 goes straight up and down, and the triangle goes at a slant. So I've got to find the length of that slant. This is 12, this center post, if you want to call it that. From the center out to the edge is half of my side. Since the side is 10, this will be 5 inches. So my slant here is going to be 5 squared plus 12 squared equals that slant squared, which will give me that slant is 13 inches. If you go through the math, I'm gonna leave that up to you at this point to do that. So now over here, my lateral area is the perimeter of the base, 40 inches, times the slant of 13 inches, and those are triangles, so we divide by 2. We're finding areas, so we're going to divide by 2. So 40 times 13 divided by 2 is 260 square inches. 13.
5 squared, 12 squared is 169, and then the square root of 169 is 13.
So that means to our 100 square inch area of the base, we add 260 square inches of lateral area. You get 360 square inches of total surface area. Anybody have both of those right? Volume and surface area? Anybody already had enough for the day? Yes? Oops, that didn't come out well. Okay, let's take a look at our sphere. I don't know why my pyramid's coming with it, but oh well. So our sphere, remember for sphere, volume, what's our formula for volume? 4/3 times pi times radius, which is 6, cubed. So 4/3 times pi times 6 cubed is 904.32. Inches cubed. How many of you came up with that for the volume? Feet cubed, thank you. I got to remember what units I'm using in this problem. Feet cubed, thank you. How many of you came up with that? Bless you again. Surface area is 4 times pi times radius squared, otherwise known as 452.16 feet squared. What do you think? Good. What's that? It's wonderful? Cool. I'm going to have to try one more, since we're having fun. Find the volume and surface area of that. Talk me through it. Not everybody at once. Okay, if you were doing the surface area, you could find 10 by 10 would give you the area of this front rectangle. Would give you 100 square inches there. What would be next? You could do 6 times 10 for this back one, yep. Which would be 60. That would be this one over here. Then you'd have 8 times 10 for this one. Would be 80 inches squared. Bless you. Now, of course, we still need to do the top and the bottom. Those are both triangles. Which two dimensions do we use to find the area of the triangles there? Well, which two dimensions make the right angle? 6 and 8. So that bottom triangle would be 6 times 8 divided by 2, which would be 24 square inches. And the top would be just like it. So we got what, 288 square inches? Does that look right? Is that what you got for surface area? No? Oh, you didn't add them all in? Okay. That's one way you could find surface area. That's the brute force, just finding each of the shapes and adding them up. That works. Let's look at the other way to find surface area, which would be to start out with the area of the base, which is the 6 times 8 divided by 2, the 24 square inches for the bottom. For the lateral area, you need to find first the perimeter of the base, which is 6 plus 8 plus 10, which happens to be 24 inches. So the lateral area is that perimeter of the base, 24 inches, times a height of 10 inches, giving us 240 inches squared, so that our total surface area is the area of the base, 24, plus there's a second base, so another 24, bless you again, plus the lateral area of 240 is 288 inches squared. So two different ways to go about finding the surface area. Volume at this point is actually pretty simple since we already have the area of the base of 24 square inches. Our volume will just be 24 inches squared times the height of 10 inches, 240 inches cubed. That's it. Questions? Okay. Now, last week when we were doing all these measurement conversions, we talked about a conversion. We didn't have a lot of time to go over it, so I want to review it a little bit here. If I were converting 4 feet into inches, what am I going to do? Yeah, it's going to be 4 feet over 1. 1 foot is 12 inches. Feet cancel out. 4 times 12 is 48 inches. And most of us just know that when you go from feet to inches, you multiply by 12. But what if it's a little bit different? What if instead of 4 feet, it is 4 square feet going into square inches? Is it still times 12? Say no. No. Why not? Because it's not inches and feet anymore. It's square inches and square feet. How does that change things? Well, it puts a little 2 after the units, doesn't it? What does that squared do? Well, remember, our conversion was 1 foot equals 12 inches. But if it's square feet and square inches, you have to square everything. What's 1 squared? 1. Foot squared is just foot squared. What's 12 squared? It's 144, and an inches squared is just inches squared. 1 square foot is 144 square inches. So if I put my 4 square feet over 1, I go to make my conversion factor, 1 square foot's on bottom, it's 144 square inches on top. So the square feet cancel out. It's 4 times 144, which is what, 576 inches squared. Look familiar? So what if I go one more step? Bless you. What if I go from 4 feet cubed into inches cubed? Well, again, we have to find our conversion factor. Looking at 1 foot is 12 inches again. It's cubed this time. So 1 cubed is 1. A foot cubed is just a cubic foot or a foot cubed. What's 12 cubed? 1,728. And an inch cubed is an inch cubed. So 1 cubic foot equals 1,728 cubic inches. So when we go to set this up, we got 4 cubic feet over 1. Now the 1 cubic foot's on bottom, it's 1,728 cubic inches. 4 times 1728 is 6912 cubic inches. Look familiar? Well, then let's have you guys try a few. Here, try those three. So for the first one, cubic yards over 1. Put 1 cubic yard on bottom. How many cubic feet are in a cubic yard? Well, how many feet are in a yard? 3. What's 3 cubed? 27. There we go. So that's 7 times 27, or 189. Anybody get that one? 1? I'm going to pause. Questions as to where the 27 came from. Because 1 yard equals 3 feet. To turn it into cubic yards and cubic feet, you got to cube everything. So 1 cubed is 1. Yards cubed is yard cubed. 3 cubed is 3 times 3 times 3 is 27. And a feet cubed is a foot cubed. Gives us this equivalency. Rods. So we got 4 rods squared. We're going to put square rods on bottom here, going into square feet. How many square feet are in a square rod? It's a really good question. There it is. 1 rod is 16.5 feet. So squared, we have to square everything. 1 squared is 1. A rod squared is a rod squared. 16.5 squared is 16.5 times 16.5, which is 272.25. And foot squared is foot squared. So the square rods cancel out. 274 times 272.25 is 1,089, is it not? Perfect. So 1,089 square feet in 4 square rods. Questions? Okay, well then down to the last one, 54 square feet. So at 54 feet squared over 1. Square feet on bottom, square yards on top. Which one's the bigger unit? Yards. So yards are going to be 1, right? We know that 1 yard is 3 feet. When we go to square, now this is squared, not cubed, just squared. So 1 squared is 1. Yard squared is yard squared. 3 squared is 9. And feet squared is feet squared, square feet. So 1 square yard is 9 square feet. The square feet cancel. 54 times 1 yard is 54 square yards over 1 times 9 is 9. That divides out to be 6 square yards. Did anybody get all 3 right? Anybody have no idea how I did any of those? Okay. So you do have to be careful. It is very, very easy to miss when you go to do conversions. That power on the unit. Remember, the power is not affecting the number at all. It is telling you that that is a different unit. That is not rods and feet. It's square rods and square feet. So it's not, this number does not change. It's the conversion factor that has to change because of that power. So now let me draw that a little better. I accept my poor artwork, but even I have standards. There, we'll pretend that looks a little bit better. We have these geometric figures. And we said these little arcs for angles indicate whether they're equal or not. If I had 2 angles marked with the same number of arcs, that would indicate they're equal. Here, I have a single arc, a double arc, and a triple arc, which is telling me all 3 of those angles are different. If I take that triangle and enlarge it, oops, that's not what I wanted to do quite yet. I want to duplicate it. Duplicate it and enlarge it. And move it over here. How do I know? I mean, I just enlarged it. You watched me enlarge it, so you know that this second triangle over here is an enlargement of the first one. But if not, how would I know that that's the same triangle? It's just been enlarged or reduced. Well, if I am told these angles are the same, then the triangle has to be an enlargement of the other one. If they have all 3 of the same angles, they have to be the same triangle, just enlarged or reduced. It's what we call similar. In similar triangles, there's what's called a constant of proportionality. You don't need to know that word. All it's saying is the amount of increase in the length of one side is the same as the amount of increase in the length of all the others. Now, I'm not saying you add a number to it. I'm saying you multiply that length by a certain number. So let's say that this is 8, 10, and 12 for sides. I'm going to leave the units off for now just for the sake of time and efficiency. If I tell you that this side here is 12, and I'm going to call this side X and Y, how do I find sides X and Y? Well, we first must find that constant of proportionality. And we find that by using a proportionality ratio. In other words, just a ratio of sides. And that's, you don't need to know the term ratio, proportionality ratio either, but the concept of a ratio of sides is important. To do that, I need to find two sides that are what we call related or corresponding. In these triangles, how do I know whether sides are corresponding? Well, because they're between the same two angles. This angle and this angle are the same. This angle and this angle are the same, which means this side corresponds to that side. So my constant of proportionality, or whatever you want to call it, involves the 8 and the 12. When I make this ratio, does it matter whether I do 8 over 12 or 12 over 8? Say no. No. Good answer. It doesn't matter whether I do 8 over 12 or 12 over 8. What matters, in this case, I put the 8 on top, right? What triangle does the 8 come from? It comes from this one. That means once I put the 8 on top, all the other links from that triangle have to go on top. Now over here, I need to decide which of my missing sides I need to find. I'm going to look for x. Does x go on top or bottom? Bottom. Why? Yeah, it's from the triangle that the 12 is in, so it has to go with the 12. That triangle is represented by the bottom of this ratio. Now on top, we have to figure out what side from the other triangle corresponds with the x, and that would be the 10. Goes between the same two angles. So that's a 10. And now we will cross multiply. When we go to cross multiply here, what two numbers get multiplied? 12 times 10 is going to be 120. And then we divide by 8. Or you could do 8 times x and get 8x equals 120 and divide by 8. X is 15. Bless you again. So x is 15 units. So now how do we find y? Well, we use that same ratio, 8 to 12. Now we got to put in y. Where's y going to go? Still on bottom. What goes above the y? 12 is the corresponding side from the other triangle. And we are going to cross multiply and divide. 12 times 12, 144. And then we divide by 8 is 16. That's not right, is it? 18, sorry. So y is 18. Not so bad? Find x and y. In your notes, find x and y for these. So to start off with, what's our ratio for two known sides? The 8 to 20. 8 over 20 or 20 over 8, doesn't matter which way. Now for finding x, where does x go? X is in the same triangle as the 8. So X has got to go on top with the 8. What goes below the X? It corresponds with the 30 from the other triangle. So now if we cross multiply and divide 8 times 30 divided by 20, X has to be 12. Now for Y. Still have the 8 over 20. That ratio is still in place. Where's Y have to go? Top or bottom? Bottom, because it's from the same triangle as the 20. What side of the other triangle corresponds to the Y? 6. Very good. So it's 6 over Y. And we will cross multiply and divide. So now it's 20 times 6 is 120. Divided by 8 is 15. Anybody get both of those? Looking at this one, the triangle, the examples I've done so far, the triangles were always in the same orientation. Here they're not. How do I know which sides go with which other sides? All about the angles. Yep. Yep. I've got the two slash angle to the two slash angle, the single slash angle to the single slash angle. Do I know if the third one is equal or not? I didn't indicate it, but I'm going to now. How do I know that that third one has to be equal? We went over this last week. All triangles must have the three angles that add up to 180. So since they both must add up to 180, if two of the angles are equal, the third one must be as well. So I'm just going to do this. I'm going to color code this quick. 20 over here corresponds to what side of the other triangle? The Y, between the 3 and the 1. The 6 over here corresponds to what side of the other triangle? The 3. Hey, there's one where we have both numbers. That's going to indicate we might be using that somewhere. 6 over 3. And of course the X corresponds with the 12. That's all that's left. So if I'm looking for the X first, does it go on top or bottom? Is it from the same triangle as the 6 or the 3? The 6, so it goes on top. What goes below it? Corresponds to the 12. So we cross multiply. 6 times 12 divided by 3 gives us that X is 24. So we still have the 6 and 3. On the other side, I want to find Y. Does Y go on top or bottom? It goes on bottom. It's from the triangle with the 3. What goes above it? 20. Very good. So we cross multiply. 3 times 20. Come on. 3 times 20 divided by 6 gives us 10 for Y. What do you think? Not so bad? Well, it is 10:02, so it's about time to go ahead and take a break. So let's take our break. We'll come back in 10 minutes, so it's 10:03, so 10:13 we'll start up again.